I will continue the problems in mechanics of properties of fluids. Already we have seen properties of solids. Now mechanics of properties of fluids problems will continue. First one, how much pressure will a man weighing about 80 kilogram weight exert on the ground when he is lying and when he is standing on his feet? First one, problems. Pressure is equal to force by area. Weight is 80 kilogram. Given area 0.6 meter square. 0.6 meter square area. So 80 into 9.8 by 0.6 meter square. When you simplify, the pressure will be 1.307 into 10 power 3 Newton per meter square. That is when the person is lying. When the person is standing, what is the pressure exerted? P dash is equal to F by A dash. Area of the foot given as 80 centimeter square. 80 centimeter square. So force is 80 into 9.8 by 80 centimeter square area. A dash here is 2 into 80 centimeter square. Area of each foot only given. Area of the foot means 1 foot area only given. So 2 into 82 foot. 160 into 10 power minus 4. That is 2. P dash will be 9.8 by 2, 4.9 into 10 power 4. Newton per meter square, of course. 49 into 10 power 3. This is 1.3 into 10 power 3. This is 49 into 10 power 3. So, second. Find the pressure exerted at the tip of a drawing pin if it is pushed against a board with a force of 20 Newton. Straight problem. They have given the force 20 Newton. You have to find the pressure. Given area is 0.1 millimeter square. Force by area. Force given as 20 Newton. 0.1 millimeter square. Millimeter square means millimeter is 10 power minus 3. Square means 10 power minus 6. So I can write this is 1.1 means 1 into 10 power minus 1. 10 power minus 7. Numerator plus 7. 2 into 10 power 8 Pascal. Right problem. Third one. An automobile back is lifted by a hydraulic jack that consists of 2 pistons. The large piston is 1 meter in diameter and the small piston is 10 centimeter in diameter. If W is the weight of the car, how much smaller force is needed on the small piston to lift the car? Hydraulic lift, Pascal's law application, hydraulic lift. Third, F by A1 is equal to W by A2. F by pi r square is equal to W by pi capital R square. F is equal to W into R by R the whole square. W into smaller one radius or diameter 10 centimeter. So it should be 10 centimeter diameter. So radius is 5 centimeter, 0.05 meter divided by larger one 1 meter in diameter. 1 meter diameter means radius is 0.5. So square 0.05 by 0.5. Simplify, you will get 0.01 weight. That is 1% weight of the car. The smaller piston exerts a force of 1% that of the weight of the car. Okay. Very clearly, we have explained the hydraulic lift principle here. Fourth one. Calculate the height of the atmosphere above the Earth's surface. Given temperature is constant. Fourth one. Pressure exerted at a height h is equal to pressure exerted by the mercury value. Pressure exerted by 76 centimeter of mercury. 76 centimeter or 0.76 meter of H. So pressure exerted formula H rho G is equal to atmospheric pressure value 1.013 into 10 power 5. Here also into rho G you multiply, you will get the answer. Density of air into 9.8 you multiply, you will get this answer. Your aim is to calculate H. 1.013 into 10 power 5 by 1.3 into 9.8. Simplify 7951 meter, approximately 8 kilometers. 7.951 kilometer, approximately 8 kilometer. Correct? State problem. Pressure is equal to H rho G formula. Here atmospheric pressure we have substituted 76 into 10 power minus 2 or 0.76 into rho density of mercury into G 9.8 multiply, you will get this answer. Fine. Next, fifth one. If the water pressure gauge shows the pressure at ground floor to be 250 kilopascal, how high would water rise in the pipes of a building? Same problem. We know liquid pressure or fluid pressure formula P is equal to H rho G. Question to calculate H P by rho G. Pressure 270 kilopascal into 10 power 3. This is water only used. So density of water is 1009.8. This 2 cancels 270 by 10 approximately. So nearly 27 meters. Correct answer is 27.6 meters. So if 270 kilopascal pressure exerted by the pressure gauge, the height in which the water rise in the building is nearly 27.6 meters. Okay. Sixth one. A barometer kept in an elevator accelerating upwards reads 76 centimeter of mercury. If the elevator is accelerating upwards at 4.9 meter per second square, what will be the air pressure in the elevator? Mercury pressure 76 centimeter. Elevator is accelerating upwards 4.9. What will be the air pressure? So normal pressure value, you know, formula P is equal to H rho G. It is accelerating upwards H rho. So I have to write A plus G. So pressure will be H 76 centimeter, 13.6, 13,600 kilogram per meter cube, 13.6 centimeter per in terms of CGS unit, 13.6. A given us 4.9 plus 9.8 whole divided by 13.6 into 9.8. Sir, pressure only asked. Why you are dividing by density into gravity? Pressure in terms of height we are going to calculate. 76 centimeter of mercury you have read now. But actually pressure is in terms of Pascal. In that H alone you are using. Here also we are going to calculate pressure. H alone we are going to tell. That we have to multiply by rho and G to get the final answer. Value is 114 centimeter of mercury. 114 centimeter. Okay. Next. How much a body of weight 70 Newton weigh in water if it displaces 200 ml of water? Laws of flotation, Archimedes principle. Volume of water displaced is equal to mass of water displaced. So here 0.2 liters, 200 milliliter, that is 0.2 liters. Nearly 0.2 kilogram. Okay. So loss of weight in water is equal to weight of the water displaced. This is Archimedes principle. Loss of weight inside the water is equal to weight of the water which is displaced. 0.2 mass into 9.8 multiply 9.8, 19.6, 1.96 Newton. So 1.96 Newton is the weight of the water displaced. So what is the apparent weight of the body? That is the question. What is the apparent weight? So apparent weight will be 70 minus 1.96. 68.04. 70 Newton weight given. So apparent weight when the loss of weight inside the liquid will be around 1.96 Newton. So apparent weight of the body when it is immersed in the liquid is 68.04 Newton. Total general weight minus weight of the water displaced is subtract, you will get the answer 68.04. This is the best example for Archimedes principle. Okay. Eighth problem. A solid weighs 6 kilogram in air. If its density is 2000 kilogram per meter cube, what will be its apparent weight in water? First, to calculate the volume. Volume. Mass is equal to volume into density. So volume is equal to mass by density. Mass is 6 kilogram. Density is 2000. So 6 by 2000. That is volume of water displaced. 6 by, let it be as it is. So mass of water displaced is equal to volume of water displaced into density. What is the volume of 6 by 2000? Density of water 1000. So it should be 12 kilogram. No, what? No. 2 will come here. So 6 by 2, 3 kilogram. Right now. Okay, next. A metal plate 5 centimeter into 5 centimeter rests on a larger rests on a layer of castor oil 1 millimeter thick. Given eta is equal to 1.55 Newton second meter power minus 2. Find the horizontal force required to move the plate with a speed of 2 centimeter per second. Viscous force based on it. Given area of the plate 5 centimeter into 5 centimeter. Viscosity 1.55. Castor oil thickness is 1 millimeter. Speed is 2 centimeters per second. Viscous force formula F is equal to eta into A into velocity gradient. Velocity gradient means velocity by distance. What you have to calculate here? You have to calculate force. 1.55 area 5 into 5 centimeter square. 25 into 10 power minus 4. Change in velocity 2 centimeter per second. 2 into 10 power minus 2. By distance, distance is nothing but thickness, castor oil thickness, 1 into 10 power minus 3. So 1.55, 25 into 2, 50, 10 power minus 6, minus 3, numerator will become minus 3. 1.55 into 5 into 10 power minus 2. That will be 0.0775. 0.0775 Newton. Correct, ma? So this is the formula based on viscous force of a liquid. Okay. So 10th problem. What would be the average velocity of water in a tube of radius 0.005 meter so that the flow is just turbulent? Just turbulent. Reynolds number formula we have to use here. What is the formula for Reynolds number, man? Do you remember? Rho Vd by eta, or Rn is equal to rho Vd by eta. You have to calculate the velocity. So I can write V is equal to R into eta by rho into d. What are the data given here? Radius 0.005 meter, viscosity 0.001. Just laminar. Just laminar means streamline, just turbulent. Just turbulent means 3000. 3000 and above is Reynolds number value in turbulent flow. Up to 2000 means it is streamlined flow. 2000 to 3000 means it is in between. Just turbulent they have given. So 3000 into eta value 0.001 by rho, density of water 1000. What is the diameter given, ma? 0.005 meter radius. 0.005 means 0.01 meter diameter. So 10 times, this is 3 times. This one and this one is 10 times. 3 by 10, that is 0.3 meters per second. So the velocity of the liquid which is flowing inside the tube is 0.3 meters per second. So these are the problems related with mechanics of fluids. Okay, thank you. We'll continue.